Find the area bounded by the curves y equals square root of x and y equals negative 1/2 x plus 1 for 1 less than or equal to x less than or equal to 4. Not quite sure what these parentheses are for, but I'm going to assume they're unimportant. Okay, so the first thing is then to find where these intersect and what these graphs look like. So we can plug it into your calculator. That'll work great, but I'm going to use Wolfram. I have it available, and I like it. So we have y equals square root of x, y equals square root of x, and y equals negative 1/2 x plus 1, y equals negative 1/2 x plus 1. That's going to be a line and a square root. So, yep. And then we're going from 1 to 4. So it looks like the square root will be greater than y equals negative 1/2 x plus 1 from 1 to 4. So we'll do the square root minus the line. Okay, we can do that. So we'll have an integral from 1 to 4 of x. I'm going to write it as x to the 1/2. That way it's more obviously the power rule. Minus 1/2 x plus 1 dx. Get another color so that I can distribute the negative. There we go. Then we'll do x to the 3/2 times the reciprocal, which would be 2/3, plus 1/2 times x squared over 2 minus x. And I don't need this integral symbol. This will be evaluated from 1 to 4. Make sure I'm not missing anything. Yeah, that seems reasonable. Okay, so this becomes 4. So we have, I'll rewrite this once just for clarity. X to the 3/2 plus x squared over 4 minus 1 from 1 to 4. And then this becomes basically just an algebra problem, which we can do because we can do the 3/2 of 4 fairly easily. So we'll do 4 first, so 2/3. So 4 to the 3/2 is the same as 4 square rooted cubed. So that 4 square rooted is 2. 2 cubed is 8. And we assume that for this problem that we're taking the positive square root. So you could be like, well, the square, negative 2 squared is 4. So square root of 4 is negative 2. Negative 2 cubed is negative 8. You're right. For this, we're assuming that the square root is going to be a positive value. Okay. So plus 16 over 4, which will be 4, minus, why is that a 1? That's supposed to be an x. Causing troubles. Minus 4. Minus, now we plug in 1 for everything, and that's going to be 2/3 plus 4. 2/3 plus, no, 1/4. 1/4 minus 1. There we go. So this is going to be a common denominator of 12. So this will be multiplied by 4, so it'll be 8/12 plus 3/12 minus 12 over 12, which is 11. So this is negative 1/12. But we still have the negative sign over here to contend with. This is probably not the correct way of doing algebra. I'm skipping a lot of steps. I'm kind of doing half over here, half over there. You should probably be more organized in life. Okay. I don't mean to take you upon my trip of disjointed algebraic thinking. So that's going to be multiplied by 4. So 16 times 4. 4 times 6 is 24. 64. Okay? I was pretty sure that was the answer, but not entirely sure. Plus equals 65 over 12. And here we got, whoop, haha, that's nice. It's always something rewarding about seeing the answer you think is the answer being an actual possible answer. So go purple, 65 over 12. Okay, this one wasn't too bad. To backtrack what we did here, we're trying to find the area bounded by the curves, square root of x, and a line, negative 1/2 x plus 1. We then, after graphing, found out that square root of x is greater than the line over the period, over the interval 1 to 4. So we subtracted the greater equation or function from the lesser function. We then took the integral of both of them, and that gave us the area under the curve, between the curves. And it turns out that we had 65 over 12. So that's how I approach this problem. That's how I do this. Thank you much. Go team.